Hello and welcome to another episode of Foreknowledge. In this video, we are going to discuss about transpose of a matrix. Fine. So we have learned about matrix, its rows and columns, and we have learned how to multiply a matrix, two matrices. Okay. Now this is another topic under the heading of matrix. This is transpose of a matrix. What is transpose? Simply speaking, if you have a matrix with some rows and columns, then just interchange the elements of rows and columns. That means the elements of rows, if you write that along the columns, and if the elements of columns, if you write them along the rows, then that is the transpose of the given matrix. Like for example, suppose A is 1, 2, 3, 4, 5, 6. This is a matrix of order. Here it has 2 rows and 3 columns. 2 cross 3. 2 rows, 3 columns. Now transpose of A. Transpose of A. We write this as A transpose. Okay, we write this as A transpose. T in the power. T in the power. T stands for transpose. Okay. So A transpose is nothing but write the elements of rows along the column. So first row will be now first column 1, 3, 5. Okay. And the second row is now second column, that is 2, 4, 6. Now with this process, what we are ensuring is that the columns are also interchanged into rows. Look, rows 1, 3, 5 is interchanged into columns, 2, 4, 6 is interchanged into columns. Now if we look at the columns of the original matrix, that is 1, 2, look, this is now converted into rows. 3, 4 rows, 5, 6 rows. Okay. So the order is also getting changed, which was initially 2 cross 3 for the original matrix. For the transpose matrix, it is 3 cross 2. That is 1, 2, 3, 4 and 5, 6. And the transpose is denoted by A with a T on its power. Okay. So this is what the transpose of a matrix is. If we take another example, suppose B is another matrix 1, 0, 3, 2, 1, 4, 3, 3, 7. What is B transpose? What is the order of B? B is a matrix of order 3 cross 3. That is, it has 3 rows and 3 columns. Fine. So B transpose is nothing but now just interchange. One interchange will ensure the interchange of another. That means interchange of row into column will ensure that the interchange of column into row. So basically 103, which is first row, now it is first column. 214, which is the second row, is now second column. 337, which is the third row, is now third column. And with this we are ensuring that the columns are getting into rows. That is 1, 2, 3, 1, 2, 3. 0, 1, 3, 0, 1, 3, 3, 4, 7. Got it? Fine. So basically, one point, look, if A has order M cross N, then A transpose has order N cross N. If A has order M cross N, then A transpose has order N cross M. That is, what was the row in the original matrix? This is now the column in the transpose matrix. And what was the column in the original matrix is now converted to row in the transpose matrix. Okay. Now if it is a square matrix, then rows and columns are equal. Number of rows equal to number of columns. So we won't find any kind of change in the order, okay, in case of a square matrix. So I hope this is clear. Let me erase this. Now there are some properties of this operation, okay. Properties. What are the properties? Number one, transpose of a transpose is the original matrix, okay. We are transposing first the original matrix, that is A transpose. Again we are making the transpose. Then the result will be the original matrix. Let's take an example. Suppose 1, 2, 3, 4, 5, 6. This is the original matrix A. So what is A transpose? A transpose is nothing but 1, 2, 3, 4, 5, 6. Fine. Now what is the transpose of the transpose? Now we have to take the transpose of this matrix. So rows will be columns 1, 4, 2, 5, 3, 6. Now look, A was 1, 2, 3, 4, 5, 6. Now A transpose whole transpose is again 1, 2, 3, 4, 5, 6. So it is verified that A transpose equal to A. This is not proof. This is just an example. Okay, this is just an example. Fine. I hope the example is clear. Now let's move on to the second property. Let's move on to second property. Property number 2. A plus B whole transpose is nothing but A transpose plus B transpose. Yes, that means if you add two matrices and then take the transpose of the resultant, that will be equivalent to if we transpose them individually and then add them. Okay, that means transpose of the entire addition is equal to addition of the transpose. Suppose A is 1, 2, 3, 4 and B is 0, 1, 3, 2. Okay. So A plus B is 1 plus 0, 1, 2 plus 1, 3, 3 plus 3, 6, 4 plus 2, 6. This is A plus B. So A plus B transpose is row column interchange, that is 1, 3, 6, 6. Fine. Now take A transpose. This is 1, 2, 3, 4 and B transpose, this is 0, 1, 3, 2. Okay. Now take A plus B whole transpose. A transpose plus B transpose. I'm sorry. Now let us take A transpose plus B transpose. What is A transpose plus B transpose? 1 plus 0, that is 1. 3 plus 3, 6. 2 plus 1, 3. 4 plus 2, 6. Now look, these two quantities. Look at these two quantities. This quantity and this quantity. Both of them are equal. So the second property is also verified, not proved. Why I am telling verified and not proved? Because in order to prove something, you have to take general concept. Okay, that means you have to take a general matrix, two general matrices, and then you have to apply the matrix operations and then transpose, and then you have to get to the final result. What I am doing, I am just telling you that yes, this formula can be verified using, if we take this as an example. Okay. Now verification is done. Okay, verification is done. So let us move on to the next one. Let us move on to the next one. Number 3. K times A whole transpose is nothing but K times A transpose with no change in K, where K is a scalar. K is a scalar. Okay. That means if you multiply a scalar term or a real number to a matrix and then take the transpose, which will be equivalent to just transpose the original matrix and multiply with the same scalar. Okay, suppose A equal to 5176. Suppose K is 3. Okay, so 3 times A. How scalar multiplication is done? You have to multiply each element of the matrix by the scalar. So 15, 3, 21, 18. Okay. Now 3 times A whole transpose is nothing but 15, 3, 21, 18. Right? And what is A transpose? A transpose is 5176. So 3 times A transpose equal to, just multiply this quantity A transpose with 3. So 15, 21, 3, 18. Okay, look, these two are same. These two are same. So again the third one is verified, not proved. It is already proven result. That's why we are using the property. Okay. Now for your purpose, I am showing that yes, this can be done. There are examples where we can show this. Okay. So done. Now final property, that is A into B whole transpose, where A and B are two matrices, compatible matrices, compatible for multiplication. Mind that A and B are compatible for multiplication, then only this property can hold. Okay, A into B whole transpose is nothing but B transpose into A transpose. Yes, you have heard me right. B transpose into A transpose. A into B whole transpose is B transpose into A transpose. Okay, let's take an example for this also. Fine. So if you allow me, I will be erasing the first three property and we'll write the fourth one in the top, and then we'll show an example. Okay. The fourth property says that AB whole transpose is B transpose A transpose. Okay. Let us take two matrices. I am taking 2 cross 2 for our calculation purpose. 1, 2, 3, 4, and B is 3, 7, 1, 6. Okay. So you have to identify first AB. We have to multiply AB. 2 cross 2, 2 cross 2. So multiplication is compatible. Okay. So 1 into 3 plus 2 into 1. 1 into 3 plus 2 into 1. 1 into 7 plus 2 into 6. 3 into 3 plus 4 into 1. 3 into 7, 4 into 6. This is what AB is. Now AB transpose will be 5, 19, 13, 45. This is what AB transpose is. Now we have got the left hand side AB transpose. We need to find B transpose first, A transpose second, and then we have to multiply them. So what is A transpose? A transpose is 1, 2, 3, 4, and B transpose is 3, 7, 1, 6. Okay, B transpose is 3, 7, 1, 6. Now B transpose into A transpose is nothing but 3, 1, 7, 6 into 1, 3, 2, 4. So let's multiply. 3, 1, 3, 3 into 1, 3 plus 2, 5, 3 into 3, 9 plus 4, 13, 7 into 1, 7 plus 12, 19, 21, 7 into 3, 21 plus 24, 45. So look, AB transpose equal to B transpose A transpose. Okay. If you multiply A transpose B transpose, you will get a different result. If you multiply A transpose into B transpose, you will get a different result. I am giving you as an assignment to calculate A transpose and B transpose and verify that AB transpose is not equal to A transpose B transpose. Okay, this is your assignment. Fine. So this is all about the transpose of a matrix and its properties. I hope this will be useful to you. In the coming videos, we'll be solving some problems using transpose of matrix, its properties, and then we'll be discussing about symmetric, skew symmetric matrices. There are some special problems about symmetric and skew symmetric matrices. We will be seeing that in later. So for now, that's it. I hope you enjoy the video. If you enjoy the video, please like, comment and subscribe our channel, and we'll be uploading more videos like this later. Thank you.